So let A is equal to the given matrix, then the characteristic equation is given by A minus lambda I is equal to 0. That means 1 minus lambda 2, 2, then 2, 1 minus lambda 2 and 2, 2, 1 minus lambda equal to 0. So on expanding this one, you will get the characteristic equation, and that is lambda cube minus 3 lambda square minus 9 lambda minus 5 is equal to 0. So on expanding this determinant, you will get this equation lambda cube minus 3 lambda square minus 9 lambda minus 5. So as we discussed earlier, you can use either the formula lambda cube minus sum of diagonal elements into lambda square. So that formula you can use, otherwise you can directly open the determinant and we can solve this question. Okay, we will get this equation. So either of this you can select. So now get the values for lambda. Solve this equation and get the values for lambda. On solving this, you will get lambda is equal to minus 1, and 5. So I hope you are getting the answer. And wait for 2 minutes. Just try that and get that answer. Good? So now eigenvector corresponding to lambda equal to, so here also you can see two values are repeating and one value is non-repeated value. Okay, so now when lambda is equal to minus 1, we need to get the corresponding eigenvector. So when lambda equal to minus 1, let a minus lambda 1 into I of x equal to 0. This be the corresponding eigenvector, and this will give you, so as we know, what we have to do is you need to subtract 1. Okay, lambda equal to minus 1, so 1 minus that diagonal, 1 minus that eigenvalue is to be subtracted from the diagonal elements. So 1 minus minus 1, 1 minus minus 1 is 2, then 2, 2, again 2, then 1 minus minus 1, so 2, 2, then again 2, 2, 2. So a matrix consisting of all same elements. So that is now, so obviously rank of this matrix will be 1 only because all the 3 rows are same. So R3 changes to R3 minus R1 and R2 changes to, same way R2 changes to R2 minus R1. So this is 2, 2, 2, then 0, 0, 0, and here also 0, 0, 0. Or sorry, here we need to write x1, x2, x3. x1, x2, x3 equal to, so here also x1, x2, x3 equal to 0, 0, 0. So now on solving this equation, so again if you need, you can write this one more step, that is r1 divided by 2, this you will get as 1, 1, 1. Okay, so that also if necessary we can write, otherwise it's okay, we can keep it as it is. So here you are getting n equal to 3, number of unknowns 3, rank is equal to 1. Therefore n minus r means 3 minus 1 equal to 2 variables can be given, arbitrarily constant means you will get two linearly independent solution. Okay, so I am putting, suppose put x2 equal to say t1 and x3 is equal to say t2. Therefore, from here, from this one, the first equation what you are getting is 2x1 plus 2x2 plus 2x3 is equal to 0. Okay, dividing throughout by 2, you will get it as x1 plus x2 plus x3 equal to 0, or x1 is equal to minus x2 minus x3. Now, if you do not want here negative sign, negative values if you do not want, we can choose this x2 and x3 in such a way that this negative will be cancelled. Okay, so you can take x2 equal to say minus t1 and x3 equal to minus t2. It's not necessary, but if you want to avoid the negative, you can take like that. So minus t1 minus t2. This is now x1. Okay. Therefore, the corresponding or the required vector is x is equal to x1, x2, x3. This is equal to x1 minus t1 minus t2. x2 is t1. So t1 and x3 is t2. So t2. Here I will write 0 t2. Here I will write 0 t1 plus. Okay, so this is equal to, again split this into 2. So it is minus t1, t1, 0 t1 plus minus t2, 0 t2 and t2, or that's equal to minus 1, 1, 0 t1 plus minus 1, 0, 1 t2. So the vectors are, the required vectors are minus 1, 1, 0 and minus 1, 0, 1. These are the two vectors x1 and x2. Okay, so for lambda equal to minus 1, we got two vectors, means lambda equal to minus 1 is repeated twice and we got here two vectors. Okay, now the case 2, second case, when lambda equal to 5. So let a minus lambda into I, lambda 2 into I is of x equal to 0. So here again we subtract 5 from the diagonal elements. So that is, you will get it as minus 4, 2, 2, subtracting 5 from diagonal elements. So 2 minus 4, 2 and 2, 2 minus 2, again x1, x2, x3 equal to 0, 0, 0. So again simplifying this one, you will get the vectors as, so here if you are trying to reduce this to echelon form, just let's try. R3 changes to R3 minus R2. Okay, so this is 2 minus 2, 0 will come here, 2 plus 4, 6 will come here, minus 2 minus 2 will means minus 4 will be here. Okay, and so let's try R3 minus R2, or we can write a 3 by 3 minus 4, where it is, just a second. Okay, means 2 minus, matrix is 1 minus 5, yeah right, 1 minus 5 is minus 4 here, minus 4. So R3 minus R2 if I do, or suppose firstly I am dividing, R1 changes to, we will make this as R1 changes to R1 divided by 2, then this becomes minus 2, 1, 1, R2 changes to R2 by 2. Okay, let it be like that only, because for subtraction that will be easier now. So this is 2 minus 4, 2 and 2, 2 minus 4. x1, x2. You need not write now this one. Okay, this is, we are going to change this. So do not write this step now. So I'm just showing you R3 changes to R3 minus R3 plus R1, and R2 changes to R2 plus R1. So it is minus 2, 1, 1, then 0, minus 3, 3, 2 plus minus 2, 0, 3 and minus 3, x1, x2, x3, 0, 0, 0. So now again, if I do R3 changes to R3 plus R2, then minus 2, 1, 1, here 0, minus 3, 3 and 0, 0, 0. Minus 3 plus 3, it is 0, okay, of x1, x2, x3 equal to 0, 0, 0. Now, that is, now here again, if we are trying to make this 0, if you are going to make this 0, some number will come here. So here the rank is 2, number of unknowns is 3. Therefore here suppose I am giving x3 equal to t. Okay. Therefore from this one, second equation, minus 3x2 plus 3x3 equal to 0. Or from here you will get x2 equal to x3, or that is x2 is also t. Okay. Now from the first one equation is minus 2x1 plus x2 plus x3 is equal to 0. Therefore from here minus 2x1 equal to minus x2 minus x3. This is equal to, now just do not do this one please. Minus x2 means minus t, again x3 minus t. So it is minus 2t, or x1 is equal to t you will get. Okay, so therefore x1, so the given means here we have taken it as x. Therefore x is equal to x1, x2, x3. So t, x2 is also t, x3 is also t. Okay, so this is equal to 1, 1, 1 of t, or the required vector is 1, 1, 1, or any multiple of t, means any multiple of this 1, 1, 1 will be the required vector. So using Cramer's rule, x1 divided by, you need to just take the minor of the other, 2, 2, then minus 4, 2 equal to minus x2, negative x2 divided by, delete the terms of this x2, take the other 2. So minor of that is minus 4, 2 and 2, 2 here, equal to x3 divided by removing terms of x3, remaining it is minus 4, 2 and 2 minus 4. So that is x1 divided by 2 2s are 4 minus 4 2s are 8. So 8 plus 4, 12 equal to, here minus x2 divided by minus 8 minus 4 minus 12, and here also x3 divided by 16 minus 4, that is 12. Okay, so this is x1 divided by, throughout now dividing by 12, x1 by 1, x2 by 1, x3 by 1, or the required vector is x1, x2, x3, that is 1, 1 and 1. In this way you will get that answer. Okay, it can be done in this way also. When the eigenvalues and eigenvectors for A is equal to 4, 6, 6, then 1, 3, 2, minus 1, minus 5, minus 2. So 4, 6, 6, 1, 3, 2, minus 1, minus 5 and minus 2. Okay. So Here also again find the characteristic equation. Characteristic equation is given by determinant of a minus lambda I equal to 0. So that 4 minus lambda 6, then 1, 3 minus lambda 2 minus 5, sorry, minus 1 minus 5 minus 2 equal to 0. Okay, so expanding this one, or by our formula we will get the equation as lambda cube minus 5 lambda square plus 8 lambda minus 4 equal to 0. Okay, opening this determinant, expanding the determinant, you will get lambda cube minus 5 lambda square plus 8 lambda minus 4. Now, on solving this one, lambda is equal to, tell me the values. Solve that equation and get the values for lambda. Get the values first. 2, 2, 1. Okay, right. So it is 2, 2, 1 or 1, 2, 2. Then you can write in any order. Okay. So now when lambda is equal to 1, because that is non-repeated value, you find the vector corresponding to that at first. So when lambda equal to 1, let a minus lambda 1 into 1 of x is equal to 0, the required eigenvector. So first step what to do is subtract lambda equal to 1 from the diagonal elements. So it is 3, 6, 6, then 1, 3 minus 1, that is 2, 2, then minus 1, minus 5, minus 1, minus 5, and minus 3 of x1, x2, x3 equal to 0, 0, 0. So now get the values for x1, x2, x3. So here also we can use a method which we used in the previous one, but I suggest you to go by echelon form. Just try. On solving, we will get x is equal to 4, 1, minus 3. If any one of you got the answer in a reverse order, 3, 1, minus 4, yeah, minus 1, 3, 4, all that is okay. Okay, so on solving this one, we got this one vector. Now for lambda equal to 2. When lambda equal to 2, consider a minus lambda 2 into I of x is equal to 0. Here also we need to get the value for lambda. Lambda value for x1, x2, x3. So we subtract 2 from the diagonal elements. So it is 2, 6, 6, then 1, 1, 2, minus 1, minus 5, and minus 4 here. Okay, minus 2, minus 2, minus 4. x1, x2, x3. And here 0, 0, 0. Okay. So now again we need to do by the echelon form. On solving that, x is equal to 3, 1, minus 2. Okay, 3, 1, minus 2 you got. So corresponding to lambda equal to 2, which is a repeated value, we got here only single vector. Okay, we got only one vector. That is the speciality of this problem. So it is not necessary that when the roots are repeated you will get 2 roots and all. When the roots are repeated you may get 1 vector also. Later in your syllabus you have some terms like multiplicity and all. At that time we will discuss this more.